So after finishing the last course, I have started another one, and the first section was a deep dive on identity and access management, or IAM. It's pretty in-depth, and there's a lot to get covered there. The basic lowdown on it is that it's where you manage and control users and the access they have to specific resources in AWS. Now, the way that happens is there are principals in AWS, and principals equal the person or description or application rather that makes a request for an action. So a principal can be a user or a role, a federated user, which is like a Google sign in or Facebook sign in when you're on a completely different website, or an application. Now, when you first create your account, you create it with the root user, and that has full control to everything. And best practice is always to put MFA on that and lock it away, and don't use it unless you absolutely have to, as with any super admin account. And then you create your IAM users after that in the IAM console. They log in with a friendly name, such as first name, last name, whatever is used in the organization, and obviously there's a Amazon resource name on the back end that stores the specific details about that account. Now, roles are interesting. They're kind of like a hybrid between users and groups, as I understand it. Essentially, you set up a role to give permissions to do actions, but it's not assigned to a single person like a normal policy would be. This role is set up and then linked to, say, a group, and anyone in that group can make a request to have those permissions, and then they're temporarily granted so that that person can do the job. But if they just tried to do the job directly, they wouldn't have access. So that's a bit of a complex topic. I'm still trying to wrap my head around that one. But that leads us into groups, which are, I mentioned this in a previous video, but good for organizing users according to their business groups and functions, and you can apply permissions to groups specifically so that you don't have to manage every individual user. And then the final part is policies, and they just define the permissions for the object. And you have identity-based policies, which means you apply them to a specific identity, like a user or a group. And then you have resource policies, which are applied specifically to resources, like an S3 bucket or a DynamoDB database, something like that. So there's a lot of principles that you can have, and the different principles authenticate in different ways. If you're trying to get into the console with a user, you're going to use a username and password, obviously, and then any applications or third-party API calls that you have are going to use access keys, which are generated on a per user account basis. Now, the identity and resource-based policies are obviously a big thing, because that's how you set the permissions for everything. Any user account created by default has no permissions to anything in AWS. All you can do is sign in. So as soon as you create an account, you need to assign some sort of policy that allows it to take actions. So the policies are stored in JSON documents that, again, control the actions of an identity. So the identity-based policies, you have two different types of identity-based policies. One is an inline, which, as I understand it, is basically you're going into the user account and modifying permissions right in there. And those take full effect, but as soon as you delete the user, those are gone. Besides that, there are managed policies, and again, there are two types of managed policies. So you have your AWS managed policies and your customer managed policies. AWS managed are all of the defaults that you have. They've created hundreds, I believe it was upwards of 500 policies that you could apply for specific permissions. But if you need something granular or need to tweak some of the default permissions, you can create your own policies and apply those as well. Resource policies are, again, applied to a specific resource in AWS, and that's really the only difference, is where they're applied. They both specify what actions are allowed and who's allowed to do them. It's really just where that processing takes place, and processing is its own beast that you go through. Besides those two policy types, there are three more that were listed. There are permissions boundaries, which control the maximum permissions for user accounts. And those work with identity policies. So permissions boundaries say a user can do this, this, and this, and it has to overlap with your identity policies. So say the identity policy tells you that you can access S3 buckets, you can access your IAM console, and you can access EC2 instances. If the permissions boundary only tells you that you can access S3 and EC2 instances, because those are the only two that overlap, those are the only permissions that you get. If you only had the identity policy, you would have access to all three. So the permissions is a way to control that a little bit more granular, in a more granular way. So if you had maybe a more junior engineer, you would perhaps give them access to the EC2 and S3 so they can do their job, but perhaps you don't trust them enough to create new user accounts. So you would put a permissions boundary on that specific user and prevent access to that while not affecting the group that you've applied your basic engineering permissions to. There is the Organization Service Control Policy, or SCP, which is very similar. It controls the maximum permissions for a group, and same basic thing applies with overlapping permissions. The identity needs to match what's in the SCP, and where there is a match, those are the resources that you are granted access to. And then finally, session policies, which are used in the roles that I talked about for temporary access to certain certain resources. Now, the policy processing is very in-depth. There is a whole flowchart on that, and there are 6 different categories within that. First, it looks for a deny statement in any of the policies applied. If there's a deny, you don't get access. Then it looks for those service control policies, the SCP, so anything applied to groups that would deny. After that, it looks at the resource-based policies, and if a resource-based policy, if I went to access an S3 bucket and there is a resource policy that says I can access it, I'm allowed access. So that almost overrides your identity policies and permissions boundaries. So if there's an allow on a resource, it takes precedence in the middle of that chain. Now, if there is no resource policy, it looks at the permissions boundaries and determines whether you have permissions there. Then it looks at session, if you have a role that's allowing access, and finally an identity policy applied to your specific user or account. So very long, very in-depth. That's a whole logic chain all by itself. But after breaking it down, it does make sense. It's just stepwise motion. Look at this. Is there allow or deny? If it's, yeah, pretty straightforward. The IAM policy structure is pretty basic. Again, there's not too much need to go too in-depth into that off the bat because there are hundreds of AWS policies, but essentially there's an effect, which is the allow or deny. There is an action, which is the specific API call that you're trying to make. So everything in AWS is an API call. So, and then there's the resource, which is what you're trying to do that action on, and the condition, which is optional and can control when a policy takes effect. So for the administrator policy that's built into AWS, there is an effect of allow, there is an action with a wildcard of star, meaning you can do anything, and then resource, again, star, so you can do anything, and there's no condition, so it always takes effect. However, you could create a more complex one, which says that you are allowed to action list EC2 instances, resource a specific group in EC2, condition, maybe you don't have one, and then deny action modify EC2 resource EC2 group, unless maybe it's for the condition, maybe it's a specific EC2 instance that you're trying to modify. So that was a lot of information. It was very in-depth. I'm still processing that and looking into roles a little bit more, but all in all, it's pretty straightforward and makes pretty good sense. So next I'll be digging into EC2 instances a little bit more, I think, and I will catch you guys then.